Hello guys, this is another tutorial from Codeworks. In this tutorial I am going to talk about Heapsort. Now before I go into Heapsort, I must first discuss what heap trees are. I am not very good at drawing in a computer, but I shall try my best. Now, unlike complete binary tree, if you have the concept, you should be knowing that in a complete binary tree all the levels are filled one after the other. Since the property the heap tree, the only difference is that in a heap tree it follows either the principle of max heap or mean heap. Now, what is the principle of max heap? Well, suppose my data structure is like this. Well, I have few elements. Let's say, let me take an example. Write those down. 44, 30, 50, 44, 30, 50, then 22. Well, suppose these are my numbers, and if I want to construct a complete binary tree, it would happen like this: 44 here, then 30, then 50, then 22 here, and like this. But as you can see, 50 is more than 44, and rest is okay for the time being. 50 is more than 44, so basically it does not follow in a specific order, it just fills level by level. Now in heap sort, this thing is avoided. What happens there in heap sort is uh, the first number insert like this: 44, then 30. Okay, it's instead from left to right, and this is my root node. First element will be inserted here, then second element would be inserted here. So this is my 30 here, like this. Then as you can see, 30 is less than 44, so no change is needed. It follows the max heap property. Then let's insert the next element, 50 here. 50 is my next element. It's inserted here. Now as you can see, 50 is more than 44. It violates the max heap property, so I have to interchange the elements like this. It comes here, it comes here. It's interchanged, and the new tree is 50, then 30, then 44. So this is how insertion takes place in a heap sort. I shall give you a complete example where I will I'm sorry, heap sort does not take place in this manner. This is the heap data structure. This is the formation of heap data structure. Now I shall okay, yeah, I shall now take a complete example and show you how it is done. Okay, this view, the numbers are suppose 44, then 30, then 50, then 22, then 60, then 55, then 77, then again 55. Okay, let's suppose these are my numbers. Let's try acting like this. Okay, fine. Now I want to construct a heap tree. Let's choose a color, is yellow. Oops. Right. brush. Yellow. Okay, yellow is looking good. Okay, first is 44, so 44 comes here. The next element is 30. It follows complete binary trees principle, so it would start occupying from left, then right. So first left, so 30 comes here. Now 30 is less than 44, so no change required. Next element is 50. 50 comes here. 50 is more than 44, so change is required. It will come here, it will come here. Then my new tree will become 50, 30 here, and here 44. Now, as I am saying it over and over again, please understand this. It will start filling from left to right. So from left means left of this parent node in the root, it's 30. 30 is left, start filling from here, then here, then here, then here. 50 is done. Now 22. So 22 is inserted here. As you can see here, 22 is less than 30, so no change required. Next element is 60. 60 is inserted here. 60 is more than 30, so a change is required. If 60 was here, 30 was here, it would violate the mass heap property, so we have to make this change. My new tree becomes 50 here, then 44 here, then 60 here, then 22 here, then 30 here. As you can observe now, even after the change, there is a discrepancy. Oops. Okay. There is a discrepancy here. It violates the mass heap property. 60 is more than 50, that is below, and 50 is above. So this has to change. So the new tree will become 60 here, then 44 here, then 50 here, then 22 here, and 30 here. Okay, now I can insert 55, and so 55 will be inserted here because this level is still incomplete. 55 will be inserted here. 85 is more than 42, so a change will occur. Let me draw it here. I have limited space. 60. Okay, I'm looking like 60. Okay, 60. Then 50 will come here, then 22 here, then 30 here, then as you can see, 55 will come below 60 here, and this becomes 44. Now I have to erase a few elements, few diagram here because I have very little space. Let's see. Okay. Oops, the black color is also going. No problem. Anyways. Let me take another color blend, brown. Brush. Okay. Next element is 77. So 77 will be inserted here. This is my 77. 77 is more than 55, so change would take place here. So my new tree would become 60 here, then 50, then 75 here, then 55, then 44, then 22 and 30. Now I have to insert 55 again, the last element here. As you can see, this is my first level filled, second level filled, third level filled, so I have to insert here 55. 55 is more than 22. A change would occur like this. Now 55 will come right, okay, yeah, 55 will come here, 22 will come here. Now 55 is more than 50, so change will come here as well. Now this will be my 55 and this will be my 50. So this is my final tree. There are no more elements, so at this point the algorithm stops. So final heap tree is 60, 55, 75, 50, 30, 44, 55, 22. As you can see, in none of the cases, in none of the levels, the parent node's value is more than the child node's value. So the max heap property is satisfied. The same thing can be done with the mean heap property. Only thing we have to keep in mind is that the parent node's value should be less than the child node's value. In every case, when the parent node's value is more than the child node's value, you have to interchange them so that the mean heap property is satisfied. So this is how insertion takes place in a heap tree. Now I'm going to discuss about deletion, but before I begin, I'm going to delete all these things. White background is better than black background. At least if I erase, the things will not go wrong like that. Okay. Now we will talk of deletion. Let me find an example. Let me draw the tree here. First element 95, then 65, sorry 85 and 70, 85 here, 70 here, excuse me, 55, 33, 55 here, 33 here, okay, then 30, 65, 30 here, sorry, yeah, 65 here, then 15, 20, 15, 22, 15, 20, 15, 22. Okay, this was 55. Pardon my drawing. Now let me draw the lines so that you can understand better. These are the two children. These are the two children. These and this. Okay. Now in order to delete the root node, this is 95. What we have to do is we must select the last element, last node, and replace the values. Like 22 will come here, and this thing will be deleted. And if I will not be replaced, it will be deleted. Now this violates the massive property. 85 is less than it's more than its parent, so a change would occur. uh, this will come here. Erase it. 85 and 22. 85 here and 22 here. Same this lines is changed now. Now 55 is more than 22. Well, as in the earlier case and in this case, 55 and 35 both are more than 22. But I will choose 55. In the previous case I chose 85 over 75 is because 85 is more than 70 and 55 is more than 35, so 55 would be replaced here. So then 55 will come here and 22 will come here. Now all the other elements are in place. They follow the massive property, and this is my new tree.